So today we are looking at the carbohydrates topic 3.1.2, carbohydrates of the biological molecules topic. So first of all, carbohydrate. Where does that word stem from? Well, carbo comes from the word carbon and hydrate comes from the word water. So carbohydrates contain the elements carbon, hydrogen and oxygen. And here is a look at the AQA specification, the area that this applies to. So carbohydrates are made up of chains of individual molecules called monomers, and the chain of repeating monomers is called polymers. So the suffix is called saccharide, so sugar equals saccharide. So therefore a single monomer is a monosaccharide. A pair of monosaccharides is called a disaccharide, and many monosaccharides equals polysaccharide. And the general formula of monosaccharides is CH2ON, and N is any number from 3 to 7. So the key points from this lesson are: monosaccharides are the monomers from which larger carbohydrates are made. Glucose, galactose and fructose are common monosaccharides. A condensation reaction between two monosaccharides forms a glycosidic bond. Disaccharides are formed by the condensation of two monosaccharides. Maltose is a disaccharide formed by condensation of two glucose molecules. Sucrose is a disaccharide formed by condensation of a glucose molecule and a fructose molecule. Lactose is a disaccharide formed by condensation of a glucose molecule and a galactose molecule. And glucose has two isomers, alpha glucose and beta glucose, with the structures as follows. And you can see that on alpha glucose the H is pointing upwards and the OH is pointing downwards, whereas on beta glucose, on that carbon, the OH and the H are flipped. So glucose is a hexose sugar, which means it has 6 carbons. So 1, 2, 3, 4, 5, 6. It's got 12 hydrogens and 6 oxygens. And on alpha glucose, on the carbon 1, the H is facing upwards and the OH is facing downwards. Whereas on the carbon 1 of beta glucose, the OH group is facing upwards. The OH and the H group are flipped. Now fructose, you don't need to know the formula for this up by heart. However, it's just to show that this is a pentose sugar rather than the hexose sugar. So, when you join two monosaccharides together, we're looking at alpha glucoses here, what happens is you take an OH from one of the groups and a H from the other group. So a H from the carbon 1 and an OH from the 4th carbon. So H2O is taken out of the molecule, and what you get is a bond that is formed, and this is known as a glycosidic bond. And when you join two alpha glucose molecules together, you form maltose. So you have your two alpha glucoses, you take an OH off the end of one alpha glucose, a H off the end of the other alpha glucose to remove H2O or water via a condensation reaction, and you get a glycosidic bond formed. And the disaccharide that you produce is maltose. Now, as you know, hydrolysis is the opposite of condensation. Hydro means water, lysis means splitting, so you split the molecule using water. So in hydrolysis, you add a water molecule to the disaccharide maltose, and your H, one of the H's goes back here, the OH goes back here, and you end up with 2 monosaccharides, alpha glucoses again. So to split the disaccharide back into its monosaccharide, you have to add water, and that is a hydrolysis reaction. So with sucrose, that is formed from glucose plus fructose. You still take H2O away, as you can see here, and you still get the glycosidic bond formed. So you're still taking a water molecule away, and you get the glycosidic bond which is formed. So, disaccharides that you need to know are glucose plus glucose equals maltose, glucose plus fructose equals sucrose, and glucose plus galactose equals lactose. So just a bit of a recap. All carbohydrates contain carbon, hydrogen and oxygen. The monomers that carbohydrates are made from are monosaccharides like glucose, fructose and galactose. Glucose is a hexose sugar, therefore it has 6 carbons. There are 2 types of glucose, alpha and beta glucose. They're isomers, and you'll need to know the structure of both for your exam. However, if you just learn the structure of alpha glucose and know that in beta the OH and the H group are flipped, so that the OH is facing upwards on the carbon 1, you should remember the structure of them both. So you've got CH2, C, 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 and then an O. So you've got your CH2OH, your H group, your H, OH, 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 OH. So I would remember that they're all these OHs are facing downwards except the 3rd carbon here, which is a H. And then to form a disaccharide, you have to join 2 monosaccharides together, and they're joined via a condensation reaction. And what you get is a glycosidic bond which is formed between the 2 monosaccharides, and a molecule of water is released. So you take H2O away and you get a glycosidic bond formed. When you join alpha glucose to alpha glucose, you get maltose. Yep, so you've got your glycosidic linkage and your water molecule goes away. And what you get is an alpha 1,4 glycosidic bond because it's between the 1st carbon and the 4th carbon. So to form maltose, 2 alpha glucoses join together by a glycosidic bond to form maltose. And it's a condensation reaction because you remove water. Sucrose is a disaccharide formed from a condensation reaction between glucose and fructose. And lactose is a disaccharide formed from glucose and galactose. And that is introduction to monosaccharides and disaccharide formation.